Straight run with landing midway. So we're going to do the class example. So that's also in the notes. That's on Brightspace. So I'm just going to write down the title here. So straight run with landing midway. We'll look at the given info. So we're given the total rise of 16 foot, half an inch. Upper construction is 12 1/4. Headroom is 7'6", and then the landing is going to be 36 by 36. Okay, so a couple different ways we could tackle this one. We could take the total rise and then divide that by 2, like we did with the, or like we're going to do with the U-shaped set of stairs, or we could try to aim for having an even number of risers. Okay, so that's what we'll go ahead and do is try to aim for having an even number of risers. So if we have an even number of risers, we then have an odd number of treads, and then the odd number is the landing, which means we have the same number of runs above and below the landing. So that's kind of what we're looking for. So the first thing we'll do is we'll put these numbers into decimal inches there, so they're ready to go. So that's 12.25, 84 plus 6 is 90 inches. So everything's ready to go there. So the first thing that we typically do is we determine the number of risers. Okay, so like I said, we want to make sure that we have an even number. So we're going to take the total rise, we're going to divide by 7. So we're looking for an even number of risers. So if we don't have that, we're going to move to get that. So we're going to take the 192.5 and we're going to divide that by 7. Okay, so 192.5 divided by 7. So that gives us 27. We don't really care about the decimals, so that's not going to work, right? One even number. So we're going to try and go with 26. Okay? We'll forget about the 27. We're going to go with 26 and then see if that'll work out for the unit rise, unit run. Okay? So unit rise is next. We're going to take the total rise, divide that by the number of risers. 192.5 divided by 26. So 192.5 divided by 26 gives us 7.4038. So 7 and 6/16, which is 3/8. Okay. So we're going to use that as 7.375 for all our calculations. Okay. Forgetting about that number, we'll have a look to see if the unit run meets code here, which it should. So 17.5 minus 7 3/8 is going to give us 10 1/8. Okay, so that's good to go. Okay. Next thing we're going to look for there is determining the height of the landing. So height of the landing could be done in a couple different ways there. We could take the total rise divided by 2, or we could also take the number of risers below the landing and multiply by the unit rise. So it's going to give you slightly different answers there. And then we can also manipulate the stringer as well to kind of make that work out. So I think we'll go ahead and follow kind of what we did in class, which was determine the number of risers below the landing and multiply that by the unit rise. Okay, so number of risers below landing, and then multiply that by the unit rise. So we could do a quick little sketch here. We have our upper floor. From there we have basically 26 risers and then 25 runs. So right, so we have 25 runs. So the odd number there is going to be the landing. So which means I then have 24 run. So 12 above, 12 below. So if I just quickly try to count that out, there's run 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. And then from there we'd have a landing, and then we have another 12 runs, okay? Just make sure that's correct. There's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 runs above the landing. Then I have the landing. So landing would sit somewhere like that. Stairs would sit on top of it. And then I have 12 runs below. This is considered to be a run as well, which is the landing. So that's together, 12 plus 12 is 24, plus 1 is 25 runs. So if I want to determine the rise, so if there's 12 runs here, that means that there's going to be 13 rises, right? So there's, which makes sense, right? There's 26 risers, so to the halfway point it's going to be 13 rises. So there's 13 rises to that point, risers to that point, multiplied by the unit rise of 7.375. That's where we're going to lose a little bit of accuracy here, okay? That's the true number. We kind of rounded that, so that's going to change it a little bit. So if we go 13 times 7.375, we end up with 95.875. So which is basically 7 foot 11 and 7/8. Okay. So if we actually took half of that, it would be 8 foot and a quarter. So there's quite the difference there, right? So if we took the height and divided by 2, we'd have 8 foot, quarter of an inch. So we're gonna have to do a little bit of playing there with the stringers to kind of make that work out. So this would work, but we could also make this work as well. But there's a difference there of 3/8 of an inch. Okay, so by code, you're allowed to adjust from riser or from tread to tread, a quarter of an inch, right? So we can kind of adjust things a little bit to kind of make that work out. So either of those answers I would actually accept, right? This is kind of what we're dealing with our cut stringer. And then this is kind of taking the total rise and then dividing it by 2, right? Taking half of 16 foot, half an inch, okay? Next thing that we're looking at there is the horizontal distance. Horizontal distance of landing from upper floor. So basically knowing where that landing is going to be, right? We just determined the height of the landing from the bottom floor. Now we want to determine the distance. So if you kind of went from here and went over vertical to that point, so what is that distance there, right? What is that distance? It's a horizontal distance of the landing from the upper floor. So if we measured from here over to the front of that landing. So one way we could tackle that is we could basically look at the number of runs there, so the number of runs above the landing. And then from there multiply that by the unit run. That's going to give it the distance from here to basically there, right? Put that in brackets, and then if we add on the landing. So in our case, the number of runs above the landing, there's 12 runs above the landing, multiplied by a unit run of 10 1/8, 10.125, plus the landing is 36. So if we put all that together, so 12 times 10.125 plus 36, that gives us 157.5. So that's 13 foot 1.5. Okay. Next thing we're looking at is getting that stairwell opening there. So first step of getting our stairwell opening is determine the number of rises / runs in the opening. So we've done that when we did stairwell openings. So we took the headroom plus the upper construction, and then we divided that by the unit rise. Right, so the headroom is given to us as 90. Upper construction is 12.25, right? And then we're dividing that by our unit rise, which is 7.375. So 90 plus 12.25 divided by 7.375. So we end up with 13.8644. I think we're going to 4 decimal places, right? Rounding to 4 decimal places. So that means I have 13.8644 rises in the opening, which means I also have 13.8644 runs in the opening. Okay? So that's going to kind of dictate what we have to do here, right? So we're trying to figure out the stairwell opening. The issue is that landing could end up in the stairwell opening. So in this case, it actually does. Okay, so there's actually 12 runs above the landing, and then we have the landing. So what ends up happening here is that the stairwell opening is actually ending up over here. Right? So there's 12 runs. So there's our 13th here, and then 0.8644 is landing here. Right, so that's kind of telling us where the stairwell opening is going to happen. So the landing is ending up in our calculation. Okay, so basically, if the number of runs above the landing is less than the number of runs in the opening, then basically your landing is going to fall into place. The only time that wouldn't fall into place is if this was 13, for example, and we ended up with 13.8644. The 0.8644 is not really worth us basically putting the landing into the opening. Okay, so it's only if this number is less than that whole number. So if the number of runs in the opening is less than the whole number for the runs in the opening, then we'd have to include the landing in our calculations. So in this case, we do. We have to include the landing in our calculations because it's ending up over here. So if we didn't, so what we have to do is basically subtract one of the runs out and then put it back in as a larger tread, which is actually 36 inches. Right, so the distance from there to there is 36. So when we do our math here for the stairwell opening, because this number is less than this whole number, we have to include it. So we're actually going to take the number of runs in the opening, and we're going to minus 1 because, like I said, that number is less than that number. And then from there, we're going to multiply that by the unit run. So I'll put 2 brackets here, okay? And then from there, what we have to do is then add on the landing. So we subtracted 1. We subtracted 1 because the landing. So we then have to add the landing in, right? So there's 12 normal treads here. And then we have a large one, so that's the one we subtracted out. And then we have 0.8644 on this side of the landing. So we're adding back in the landing there, in this case, and then adding on 3 inches. So if we're actually writing down the numbers here, number of runs in the opening, we actually have 13.8644. We're going to minus 1 because that number there is smaller than that one. So you're only going to minus 1 if that number is smaller than that one. And then from there, we'll multiply that by the 10.125. And then we'll go ahead and add on the landing, which is 36. And then the 3 inches for riser material, nosing, all that kind of stuff, shimming allowance. Okay, so we're basically going 12.8644 times 10.125 plus basically 39 inches there. So that ends up being 169.25205. So we'll divide that by 12. That's going to give us 14 feet. Minus the 14 there, we're left with decimal feet, so multiply that by 12, that's going to give us 1 inch. minus the 1, we're now left with fractions of an inch. We'll multiply that by 16. That gives us 4/16, which is reduced to a quarter. Okay? And that's basically it. We could get the angle, I guess. Maybe the total run. Maybe we'll just do that total run. It's on the example there. Okay, so the total run would be the distance from, if we dropped a level or a plumb bob, and then we measured from that point all the way to here. That would be the total run. It's not really allowing for materials from that dot to that dot, total run. So if we take the number of runs, right, and we're going to minus one of those because of the landing. Okay, so number of runs multiplied by the unit run, and then from there we'll add on the landing. So we're not going to add the 3 inches, right? We just want to know how far does the stairs travel horizontally. So there's 12 runs here, there's 12 runs here, so that's 24, right? So if we took the number of runs, we're going to be going 25 minus 1. Why? Because there's 12 here, and there's 12 here. So we want 24 times the unit run, which is 10 1/8, so 10.125. And then from there, we'll add on the landings. The reason why we took off the 1 is to add that landing in, which is larger. And that'll tell us the total run without worrying about materials. Okay. So if we went 24 times 10.125, that's basically what we're doing there. And then add on the 36. So that gives us 279 inches. We'll divide that by 12. That gives us 23 foot 3 inches basically. So just minus the 23. That's decimal feet, so we'll times that by 12. That gives us 3 inches. Okay, so 23 foot 3 as our total run. Distance from here to here, not allowing for like a ledger board or nosing material or that kind of a thing. Okay, so we have to adjust a little bit depending on the size of our ledger board. Okay, that's good.